We give a presentation on behalf of partners of the Baltic and global MFC and global coupled MFCs, and the Arctic MFC also as well. I don't need to say what we want anymore. I think you've heard enough for the previous two presentations. I'll go through the real-time forecast and Reanalysis systems, what they are now, the recent novelties and the next novelties. So if we look at where the ice is in CMEMS, there's the Southern Ocean, which is where there's most sea ice in the austral winter. The Arctic Ocean, which is more populated. You see the area range and population. Then, of course, the most say important sea ice in terms of how many people are impacted are actually in the Baltic Sea, because you have 85 million people who are living around the Baltic Sea. So there's other places where you have sea ice as well within the CMEMS areas, but I'm not going to go through them. So what are the real-time forecasting systems now? Those who provide 10 days forecast. So there's the global model, the global coupled, the Arctic and the Baltic, and there's you see a list of different sea ice models. The codes are indicated, the resolution, and the rheology. And rheology is mostly the same. And then you see that some have the ITD, the ice thickness distributions, and the others don't. And what forcing they use. The novelties are indicated in bold, and that's the estimation of sea ice concentration in the global MFCs and sea ice thickness in the Arctic MFC. And in the fast ice, that's been included in the Baltic. So in the global MFCs, you've seen that on 1st of January 2015, the sea ice concentration started to be assimilated. And if you look at the skill scores, so 1 being perfect and 0 being bad, the scores are much improved after the estimation of ice concentrations, both in the Arctic and in the Antarctic. What you see, now we jump to the Baltic Sea, where there's been no data assimilation, but work on the tuning of the thermodynamics, which has improved the area extent. So if you see an example of a maximum ice extent in 2014, there was too much ice in before tuning, and now the tuning has resulted into a nice extent, which is almost exactly like the observations. And then as well, you have the inclusion of fast ice, a parameterization for the ice that is attached to the coast. And you see around Bothian Bay that there's this blue line that separates the fast ice from the ice that is drifting inside of the bay. And that's the place where it's possible to navigate. So it's quite important to have that resolved in the model. Now I'm going to the real-time, not the real-time, but the reanalysis systems. And there's not one, but 4 reanalysis from the global, for the global area. You see that they're well, it's mostly the LIM model or the sea ice 4 model coupled to NEMO. And so I think they all assimilate sea ice concentrations. The global coupled has, of course, a coupled atmospheric model, and it does as well assimilate sea ice concentration. The Arctic MFC is regional, it covers the Arctic. It uses an older sea ice model, but it assimilates sea ice thickness and sea ice drift, SID, in addition. And the Baltic MFC has done a new reanalysis based on the LIM3 model, so the one with the ice thickness distribution coupled with NEMO. And so you'll see what the estimation of sea ice thickness does in the TOPA system, so the Arctic MFC model. And to the left, you have the observations from combined Cryosat-2 and SMOS. Those that will be included in the sea ice stack, as Cecilia has shown earlier. The assimilative system that assimilates only sea ice concentrations, and the one to the right that has assimilation of both sea ice concentrations and ice thickness. And you see that it does move the pack of thick ice in the correct direction. So that's did improve by 12 to 20% of the thick ice thickness. What does in terms of say the big picture, and by the big picture we're talking about the thinning of the sea ice, which is a big issue. It's how much volume of sea ice is being lost in the present warming. So you have in black the lines that are related to observations, and that's an interesting time because in the past decade you had ICESat, one satellite that has been interrupted in 2008. You had Cryosat-2 that started in 2010, and you have a gap of 2-3 years without any satellite data. no overlap, no cross-calibration, and some in-situ measurements, which you see there's the line that crosses in the middle. And in this, say, Aura IP exercise, there's been a comparison of different models, so what ice volume you get from global and regional models. And you see that the trend is the same, it's going down. You see the impact of the years 2007, 2012, which were the years with extremely low ice concentration. So that's also years with very low ice volume. But then in the magnitude, I mean, how much ice volume there is, there's still a large uncertainties, not only in observations, but the models are all over the place. So you'll find the 4 global MFC models in there. You'll find the Arctic MFC, which is a line that is quite low. Actually, it's predicting very thin ice. And so that's just a reflection of how much uncertainty there is in the field. Going back to the analysis in the Baltics, you have seen the tuning of ice concentration of ice in 1 year. So on a reanalysis scale, so you see that this is able to capture the interannual variability of ice in the Baltic. And you see that the Baltic can be, say, from very little ice to completely full of ice on extreme years. And so you can actually not distinguish these lines now. Then what will happen in the future? So in the, by the end of this phase of Copernicus, you will have, say, all models will use an ice thickness distribution. So starting with the global model, which will use LIM3, the global coupled with size 5. It was already using ITD, but will increase the resolution of the weather model. The Arctic will have 2 sea ice models, one coupled to the ocean, size 5, and the NERSC model, which is run in standalone. So you need to be careful which model you want to use. And in the Baltic, the LIM3 will be used as well as in real time. So the NERSC model, the one that is used on ice only, does, well, all what you see in the animation, that does simulate the ice concentration, but as well, it does all these features, the cracks and the ridges that are, say, visible, not really visible, but you see the leads, at least in low concentration, with a different rheology, and that's where the things are different. So I'm putting now this view of the sea ice damage. So it's not a fair comparison to other sea ice models because it's a variable that is only used in this Maxwell EB rheology. And then you see why this model is using this kind of rheology. You have this lightning of ice deformations and ice damage in the sea ice, and this is with the processes that are actually at stake when you have sea ice motions. So this, we believe, should be better simulated by this model, and hopefully the drift of sea ice will be better forecasted as well. So in Reanalysis, this product will not come in Reanalysis, unfortunately, but you'll have still a lot of differences between the Reanalysis that you have now and the end of the contract. So there'll be a new Reanalysis, I've heard, from the global Mercator Gloris Reanalysis with LIM3. And the global coupled will be, I believe, as well upgraded. In the Arctic, we'll increase the resolution of our reanalysis, and the Baltic will as well increase the resolution of their reanalysis. So the ITD, if you look at what that does in the global reanalysis system, so when going from LIM2 that has no ice thickness distribution to LIM3, the deviations of ice thickness are much smaller. And then with further tuning of the many parameters of the CS model, you can obtain a further reduction of ice thickness errors. So that's a quite critical step to do the tuning of the model correctly. What we can see further after that is that there's not only ice in the Arctic. When you have the Copernicus services, you have as well access to biological wave information, and that allows us to look at other things. So you have ice concentration here, and if you want to look at the biological production in the Arctic, you can see this model animation based on the real-time system. You have a bloom that comes from the south. It blooms earlier in the south, and then it blooms earlier in the warm waters of the Atlantic current, and then the bloom gains all of the waters. The sea ice retreats, and when the sea ice retreats, it leaves as well nutrients and light available to the plankton. And you see that the bloom remains longer close to the ice edge. So that's a hard thing to observe, but we know it is here. It's been seen before. so that with the Copernicus Marine Services, you're able to simulate simultaneously ice concentration, ice, primary production in the ocean, and have them consistently with the same ice edge. And that's the only thing, that the only system in which you can have this kind of correspondence. Then the waves are as well reaching the sea ice, and there is waves under ice to some extent. But before I go to that point, I need to mention what there is life under ice, and the light is going through the ice if there's low concentration or if the thickness is low as well. And you see here a simulation of how much that impacts the primary production. You see it can increase primary production by up to 10%. And 10% is important because there's a trend of primary production by 30% in a decade. So this shows that you must take both ice concentration and ice thickness into account when calculating light availability. And now, going in the end to this wave under ice, the waves do interact with the ice. They break the ice in smaller flows. The smaller flows scatter the wave, and there's this interaction of waves in ice that is, well, for the first time integrated in the wave forecast. So you see that the wave forecast from the Arctic MFC, from Met Norway, is introducing, since March, a parameterization of the attenuation of waves into the ice. So if you have a first guess of where there is waves under ice, you can look at this system and be sure that if you are in the ice, you don't really want to have waves as well. It's kind of dangerous. So in conclusion, there's been progress in the past contract, mostly on data simulation and progress on sea ice modeling for the Baltic. Now, in this present phase, there's mostly efforts on the sea ice modeling and better parameterization, better tuning, and new sea ice models. Now, CMEMS does give an opportunity to treat coupled problems of ice and biology, ice and waves, and that's a good opportunity for us. And if we want to look at points of improvement, so the snow is one variable that is very not very well observed. And I see that there's as well a new sea ice model called Ice Cube, which is being developed that will take, say, a synthesis of the developments in LIM and in the size models. So that's a very positive development.